Welcome back. Hononegah, Algebra 1. This is getting ready for our test, and this test is on only the sections 9-6, 10-1, 10-3, and 10-4. And I'm not sure, again, I'm doing these videos quite a bit ahead of time, so I'm not sure exactly what this test will look like. Probably be another Google form in which you'll have some multiple choice or maybe even have some free response questions. So please do the best you can, and so that your teachers can get feedback and obviously your grade can go up. So if you have any questions, make sure you show up to the Google Meets that the teachers are hosting or the Zoom Meets the teachers are hosting. So here we go. Solving. So solving a system. So if you have y equals 2x squared minus 2x plus 1 equals x plus 1, because ultimately y on the first one is equal to y on the second one, so therefore they must equal each other. Then it's a quadratic, so I'm going to set this equal to 0 and solve. And this you can solve in any method you want. I'm actually going to do a GCF, so I can take an x out of both of them and then set them equal to 0. So I get x equals 0 and x equals 3. So now I'm going to come back over here and put 0 in for x and get 1, and put 3 in for x and get 4. So giving you a visual as to what you're talking about, it's a parabola with a line that goes through it in which it crosses in two locations, 0, 1, and 3, 4. Next one, again, y equaling y. So I have two equations in which y equals, so I'm going to set them equal to each other. I'm going to make this equal 0, so I'm going to add x squared. I'm going to add 2x, and I'm going to add 1. So I added x squared to both sides. I added 2x to both sides, and then I added 1 to both sides, so that all equaled 0. Now, this one's not factorable. There are no factors of 8 that are going to get you 1. So my methods of solving now become more limited. I'm going to use negative b plus and minus the square root b squared minus 4ac all over 2a. So I'm going to use the quadratic formula. The discriminant, the stuff under the radical, is the hard stuff. 1 squared minus 4 times 1 times 8 is negative 31. Well, I can't take the square root of a negative. So therefore, the answer is no solution. If I was going to graph this, you're talking about a parabola and a line that actually never cross. Last one. Or I should say, there's one more here. Sorry about that. Set the two equal to each other. I'm going to add 3x squared so that everything's on one side. Now, you have options here, and this one's actually not factorable. Actually, it is factorable. I can take a 3 out, and it factors. X plus 1 times x plus 1. So I set these equal to 0, and I get x to equal negative 1. Now, you could have used the quadratic formula. A would have been 3, B would have been 6, C would have been 3, and then you could have gotten the same thing. So now x equals negative 1. I'm going to come back over here, plug negative 1 in for x, and I'm going to get negative 3. So now, there's only one answer because you have a parabola and a line that touches in one location. Now we have our last one. X squared minus 5x minus 2 is equal to 2x minus 7. Subtract 2x, add 7. Now, this one's not factorable again. So again, if something is not factorable, I need to resort back to the quadratic formula probably in order to solve. So negative b plus and minus the square root, b squared minus 4ac. I apologize there. I ended up having to cough there, so it ended up causing me a little bit of issue. So going back over here is what I had going. Negative b plus and minus the square root of b squared minus 4ac all over 2a. Now, this one's not going to be very nice. I'm not going to lie. The discriminant ends up being 49 minus just 29. And so 7 plus or minus the square root of 29 is 5.39 over 2. So now 7 plus 5.39 would be 12.39 divided by 2, which is 6.195 or 6.2. And then 7 minus 5.39 and divided by 2, I get 0.81. So now, if I plug 6.2 in for x, so 2 times 6.2 minus 7 is 5.4, and 0.81 times 2 minus 7 is negative 5.38. So again, these are not very pretty decimals, but we're talking about a parabola and a line that's crossing in two locations, and those two locations just happen to be decimals. So understand you can round to the nearest hundredth if necessary when solving. Next, we're talking about domain. The domain is always whatever is under the radical must be greater than or equal to 0. So we're not graphing this, we're just describing the domain. So the x values, if you were going to do an xy chart and graph this function, you're talking about the only x values you're allowed to use is when x is greater than or equal to negative 2. So whatever is under the radical must be greater than or equal to 0. Now, you're dividing by a negative 1. So the x values that you're allowed to use in this case are all values that are less than or equal to 0. Because when you divide by the negative, it causes the symbol to switch. And so whatever is under the radical must be greater than or equal to 0. So when you're trying to find the domain, the values that you're allowed to use, you must set whatever is under the radical greater than or equal to 0 and solve. Now we're going to use that to actually graph. So find the domain. So x has to be greater than or equal to 0. There's my domain, which means in my xy chart, I must use 0 and numbers that are greater than 0. So 1 and 4 and 9. These are all numbers that are greater than 0. And some of you might be asking, well, why in the world are you picking those particular numbers? Because when you plug those in, square root of 0 is 0 times the negative minus the 6. So again, now I'm going to start plugging these in. Square root of 1 is 1 times the negative minus the 6. Square root of 4 is 2 times the negative minus the 6. And square root of 9 is 3 times the negative minus the 6. So I'm going to plot those points. 0, negative 6. And that's your starting. That's your initial value of and so everything goes from there. So 1, negative 7, 4, negative 8, 9, negative 9. So now the range, all the values went less than negative 6. Notice all the y values went down from there. And then comparison, using our vocab. The negative sign in front is a reflection on the x-axis. Nothing inside the radical, so on the outside, now you're talking, and there's no multiplication, so there's no vertical stretch or vertical shrink. And so now we're talking about a translation down 6. Okay, let's try another one of those. Whatever is under the radical, and I'm going to put this over here, whatever is under the radical must be greater than or equal to 0. That is your domain, which means the start of your XY chart is negative 3. Plug more numbers in now that are greater than negative 3, like negative 2, for instance. Positive 1 would be a good number to put in. 6 would be a good number to put in. So again, these are some different numbers that you can put in. Negative 3, if I plug negative 3 in, I get 0. Square root of 0 is 0 times 2 is still 0, minus 1. Negative 2 is 1. Square root of 1 is still 1 times 2 minus 1. 1, I get 4. Square root of 4 is 2 times 2 would be 4 minus 1. And then 6 plus 3 is 9. Square root of 9 is 3 times 2 would be 6 minus 1 would be 5. So plotting those points, negative 3, negative 1, negative 2, positive 1, 1, 3. And so now the range, all the numbers for y went greater than or equal to -1. And let's talk about all the comparison. The 2 outside, that is a vertical stretch by 2. Now, the number inside causes a translation left and right. So this is a translation to the left by 3. And then it's also a translation, the number on the outside is a translation down 1. So I don't have a lot of room, so I just kind of put translation left 3 and down 1. Solving. So now everything's going to be the opposite operation. So I'm going to subtract 2 from both sides. I'm going to square both sides. And then I'm going to divide by 3. So everything is the opposite or operation in order to solve. Now, basically what you always have to remember is any of your answers must work in the actual problem. And as long as there's no negatives involved, then the answer should work. So as we go through this, if you plug 12 back in, it would work. So you always have to kind of check yourself for what's known as extraneous solutions. So the next one, I'm going to subtract 9 from both sides. So I see negatives, so I got to worry about this. I'm going to divide both sides by -1. Good so far. I'm going to square both sides. And then I'm going to divide by -1. So I get x to be -25. Be careful. When I plug -25 back in, it actually does work. -25 is a positive. And so the square root of 25 is 5, and 9 times 5 is 4. So again, check your solutions and always make sure. It's not every time you get a negative, but you always got to make sure you're okay. Opposite operation. So I isolate the radical. And now we got an issue. The square root of x minus 9 equals -1. You cannot have any square root cannot equal a negative. This is a no-no. So this situation right here in which you got the square root equaling a negative causes a no solution. So you cannot have a radical equaling a negative. So as soon as I saw that, I knew, hey, that's not possible. That's going to be no solution. Squaring both sides. So I square both sides to get rid of the radicals. Solve now. This is an Algebra 1 question from first semester. So I'm going to solve. Add 21, I get 39. Divide by 13, I get x equals 3. Again, always double check that your answer isn't going to cause an issue. Plug 3 back in for the x's. So 8 times 3 is 24. Minus 21 would be 3. 18 minus 15 would also be 3. This answer works. If I see a cube root, I'm actually going to cube both sides. Cubing, you can always have cube roots can equal anything. So if I cube both sides, I get rid of the cube root and solve. So there is no issue with extraneous solutions if you have a cube root. So you don't even have to check it. If it's a cube root, every answer is going to work. Last one here, I'm going to square both sides. Now, set it equal to 0. So I'm going to subtract 8v and subtract 33. Factoring. So I'd have v minus 11 and v plus 3. So factors of -33, that would get me -8. Set the parentheses equal to 0 and solve. So I get 2 answers. But again, always check to see if your answers cause any issues. And actually this one will not work because -3 equals 8 times -3 plus 33, and that can't happen. You can't have a radical equaling a negative, and so therefore the only answer to this question would be v equals 11. More solving. So divide by -9. Again, this is a no-no. You can't have a square root equaling a negative. So the answer to this is no solution. So when you go to square both sides, if the side you are squaring is negative, that is a no solution. Inverses, and we just got done in our last section, 10.4, talking about inverses. So the original, there's the original, the inverse, you take the x and the y and switch places. So the x and the y. Now, you can't just leave it like this. You actually have to solve it for y. So I'm going to multiply everything by 2 to get y equals 2x minus 6. So the original question and the inverse. You take the x and the y and switch places. So here's the original question. I always like to rewrite it so that I see the original and then I see the inverse. So you notice that I took the x and the y and switched places. I now am going to solve this for y. So now I always, your teacher may be different, but I always, anytime I multiply or divide by a monomial, I split it up into 2 fractions. So again, since x plus 8 is being divided by -5, I'm going to divide both of these by -5. Find the inverse and graph both. So here's the original. So now it's the same question we just got done doing. It's just now they want me to actually graph it. So I'm going to solve this for y. So I get negative on fx plus 5. Again, this is the reason why I split this into 2 fractions. So I'm going to change colors here. The first one's going to be in red. So the original has a y-intercept at 10 with a slope at -2. So -2 over 1. So there's the original line. The next one I'm going to do in blue. So the next one's going to have a y-intercept at +5 with a slope of -0.5. So down 1 over 2. So there's the inverse. Same question. Here's the original question. I always like to box in the original question so I know I'm supposed to graph that. And then I write the inverse. I'm going to solve the inverse for y. Now I need to multiply everything in this question by -2 in order to get rid of the fraction. So I get -2x, +8 equals y. And again, I should have probably switched colors there. But the original one crosses the y-axis at 4 with a slope of -0.5. The second one crosses the y-axis at 8 with a slope of -2. So the original and its inverse. This is just to throw in a little bit. This is from sections, previous section, in which you're solving by any method you want. So you can solve this by the quadratic formula, you can solve it by factoring, you can solve it by square root property. This is all the different ways we have learned to solve. So I'm going to use the quadratic formula here, even though I believe this may be factorable, not sure. But a is 3, b is -18, c is 12. So -b plus and minus the square root of b squared minus 4ac all over 2a. So using the quadratic formula. Now, pull out a calculator. You're going to need -18 squared. And then 4 times 3 times 12. So you get 180. Now, the square root of 180 is a decimal. So 18 plus and minus 13.4. 2 divided by 6. And so now these are 2 different answers. 18 plus 13.42 and divide it by 6 and you're going to get 5.24. There's one answer. And then 18 minus 13.42 and divide it by 6 and get 0.76. So that's solving by the quadratic formula. The next one. I can solve this by the square root property. Anytime you only have an x squared, you should isolate the x squared and then take the square root of both sides. So I get plus and minus the square root of 5, and the square root of 5 on my calculator is 2.24. So plus and minus, rounding to the nearest hundredth, 2.24. And then the last one, I'm going to set this equal to 0. And this one's a pretty easy factoring question. Factors of negative 16, that would get me negative 8. Now, if you're a quadratic formula person, you should probably just always do things with the quadratic formula. But if you can learn to factor at least simple ones in which the a value is 1, now it speeds things up. So I set things equal to 0, and I solve. So now, that was the last lesson, or the last one. We'll have a test then coming up. If you have any questions at all, please make sure that you talk to your teacher. Be safe, okay? And if there's anything anything that the teachers can do to help you, please make sure that you ask.